Hi, in this video I'm going to be talking about the descending tracts of the spinal cord. So these are the tracts that supply your motor to your limbs and to the rest of your body. So as with the ascending tracts, it's important to be able to understand and recognize this diagram and work out if you had a lesion, say affecting this anterior portion, what effect you'd see on the patient because of the tracts that would be affected. This might seem intimidating at the moment, but one thing that you can hopefully find is that this video will help explain what the different tracts do and where each one is, so then you can bring them together more easily. So motor neurons can be split into two parts, and a motor tract has these two neurons. First, we have an upper motor neuron, which runs from your cortex in your brain down to the point of the first synapse, which is variable, and then you have a lower motor neuron, which runs from your synapse down to the muscle. So there's a helpful mnemonic for working out if an injury to a muscle is in an upper or lower motor neuron, and that's the reason that the muscle is not working. So this is called hens for my farmhouse, where hens is the signs of an upper motor neuron lesion with hyperreflexia, extensor plantar reflex, no muscle wasting, and spasticity, and then for my farmhouse being the lower motor neuron lesion, so flaccid paralysis, muscle wasting, fasciculations, and hyporeflexia. So the first of our tracts that we're going to talk about is the corticospinal tract, and this is the main descending motor tract. This originates mostly in the primary motor cortex, but also the supplementary motor area is where some of the fibers will arise. It can be broken into a ventral and lateral part, and you can see here that this affects how the fibers travel down. So most of the time, the fibers will travel from the cortex, and the upper motor neuron will travel, and then 80 to 90% will decussate in the pyramids of the medulla. So these are your medullary pyramids, and they'll decussate and run in the contralateral lateral corticospinal tract. 18% won't decussate and therefore will stay on the ipsilateral ventral corticospinal tract. And these will then decussate at the level at which they then leave the spinal cord. 2% do not decussate at all, so these will run down the ipsilateral lateral corticospinal tract and then will synapse at the level at which they leave and remain uncrossed. So all of them will synapse at the level at which they leave the spinal cord. So you have 80% traveling in the lateral corticospinal tract and then synapsing and leaving. You have 18% staying ipsilateral and traveling in the ventral corticospinal tract and then decussating at the level at which they terminate and then synapsing at this level as well, and then the lower motor neurons leaving, and then 2% will remain uncrossed and travel in the ipsilateral lateral corticospinal tract and remain uncrossed. So next we have our rubrospinal tract. So the rubrospinal tract gives you some tone of your upper limb flexor muscles, such as your biceps, and these play an important role in learning to crawl as a baby. But in the adult, they have a fairly unimportant role. These originate in the red nucleus, which sits in the midbrain, and then will decussate again in the midbrain at your ventral tegmentum. So these fibers will originate here in the red nucleus, then they'll decussate. They'll then travel down in your rubrospinal tract on the contralateral side, and then will synapse at the level of termination. So as you can see here, they'll have travelled down this rubrospinal tract, then travel to the ventral horn, where they will synapse, and then they'll leave. So they synapse at their level of exit. The vestibulospinal tract can be split into two parts, the medial and lateral vestibulospinal tract. It has the function of providing tone to your anti-gravity extensor muscles. So this allows you to essentially act against gravity and can allow you to provide extensor thrust when you are beginning to fall down. So these will originate at your vestibular nuclei, and your lateral vestibulospinal tract originates at your pontine vestibular nuclei because it sits across the pontomedullary junction, and your medial vestibulospinal tract originates in your medulla. And I find that's easier to remember if you remember that the medial one is in the medulla. So these fibers will then travel down in their respective parts of the vestibulospinal tract and then synapse at the level at which they exit, and then they'll leave as their lower motor neurons. So the medial part runs in the medial longitudinal fasciculus. So the medial longitudinal fasciculus, if you remember from your cranial nerves, connects cranial nerve 8 to cranial nerve 6 to cranial nerve 3. But also it runs down the spine from our cranial nerve 8 to form this medial vestibulospinal tract into the spinal cord. And this also is worth noting that this will then, because it's running medially, then will decussate at the level at which it terminates. And this is mostly used for our neck and trunk muscles. Our lateral vestibulospinal tract will run in the lateral vestibulospinal tract, and it will not decussate. Next, we have our reticulospinal tract. So this gives us a voluntary movement of our more proximal muscles. And the reticular formation from which this originates is one of our very old parts of our brain. So that's why it provides movement to our proximal muscles. So it's very basic movements. It also gives you some reflex activity and muscle tone. And as the reticular formation has roles in consciousness and arousal, it's worth remembering that an important part of checking sort of how conscious somebody is checking their muscle tone. So therefore, if you lose this, then you can lose part of your reticular formation function and lose muscle tone as well as consciousness. So this can be split into a medial and lateral part. This time, unfortunately, the medial part's pontine and the lateral part's medullary. So this is the opposite to the vestibulospinal tract. The medial reticulospinal tract originates at the reticular formation in the pons and doesn't decussate, and it provides extensor control to our proximal muscles. Our lateral reticulospinal tract, on the other hand, starts in the medulla, and some will decussate at the level of termination, so this is a bilateral supply, whereas the previous one, the medial, doesn't decussate, so that was ipsilateral. So this is bilateral supply, and it provides flexor control to our proximal muscles. So that is essentially how your descending tracts work. So if you then go back to that diagram at the start of the lecture, this will explain where each of them runs, so you can start to think about the different signs you'll see if different tracts are damaged and how they can become damaged. Thank you for listening.